ahead and look at R5, and we want to talk about the academic vocabulary. So first, we want to know what domain is. Domain is all values that make the expression defined, and that's going to be explained further as we go along in the year. Now, we want to talk about how that refers to a rational expression, which is what we're going to be working with today. A rational expression domain is a set of all real numbers, except those that make the expression equal to 0. That means that we cannot have a 0 in the denominator. So whenever we have a domain where it's equal to 0, we call those excluded values. And that's what we're going to be working with today. So I have the steps. We can use these steps for numbers 1 through 4 on this page. And let's go ahead and go with the instructions. It says find the domain of the expressions. For step 1, we're going to factor the domain. We're going to factor the denominator. And then we're going to set the denominator equal to 0 to find where the expression is undefined or excluded. And then we solve for the variable. And then we're going to use step builder notation to state the excluded values where the denominator equals 0. So let's go ahead and show you what that means. So in this case, for number 1, we're going to say, can we factor the denominator? No, because it's already prime. And then we're going to set the denominator equal to 0. So I'm going to say a plus 9, that's a 9, equals 0. We're looking for where it's undefined. That means we're going to solve for the variable. So this is step 1. Step 2, so I'm going to say minus 9, a equals negative 9. And then we're going to use set builder notation to state the excluded values. This right here is the excluded value. Okay, so then we now say a such that a cannot equal negative 9. And if there's more than one number, we just put commas after each number. All right, let's go ahead and look at number 3. Number 3 says x squared minus 64 over x squared minus 6x plus 5. So it says step 1, factor the denominator. So the denominator is x squared minus 6x plus 5. I'm going to go ahead and use the AC method, where a equals, you're defining what a, b, and c are. A is going to be 1, b equals negative 6, and c equals 5. So I have a times c, and that's equal to 1 times 5, which is 5. And then we're trying to build b, which is going to be negative 6. So in this case, we want to say, we want to talk about the factors of 5. So that's going to be 1 times 5. We know they both have to be negative because when we add them together, we get negative 6. So let's see. It's going to be x squared minus 1x minus 5x plus 5. And then we group x squared minus 1x minus 5x plus 5. Find our GCFs. Minus 1, negative 5. It's minus 5. Or minus 1. And then we get our factored form. X minus 1. Right, because that's the repeat group. And then we get our GCF group. Remember, they're both GCFs. So x minus 5. Okay, step 2 says solve for the variable. So set the denominator equal to 0. Okay, so that's step 1. Step 2, this is called the zero product property. So what we can do now is say x minus 1 equals 0, and say x minus 5 equals 0. And again, step 2 says solve for the variable. I need to change those steps. So we're going to say plus 1, x equals 1. And then plus 5, x equals 5. And then our last step is going to be use set builder notation to state the excluded values. These right here are the excluded values. So we're using the variable x such that x cannot equal, remember they're excluded, 1 and 5. Okay, let's look at number 4. So it says y is divided by y squared minus 9. We want to use the same steps, but the first thing we want to know or recall is that denominator is called the difference of squares. So when we factor the denominator and set it equal to 0, we're going to go ahead and use that strategy for difference of squares. So step 1 is going to be, y squared minus 9. And we're going to use a difference of squares to factor this. So it's y and y, 3 and 3. Remember, because these are perfect squares, so we're going to say plus and negative. These are still equal to 0. So now you set each binomial equal to 0. And this is 0 product factoring. Let's look at number 4. Y divided by y squared minus 9. The first thing I want to notice is that the denominator is what we call the difference of squares. So when you factor the difference of squares, you're using the conjugates. So step 1, y squared minus 9 equals 0. And then we factor y squared minus 9. So the square root of y is y. The square root of 9 is 3. And then we just put positive and then negative. Remember, conjugates means they use the same terms but different signs. And then set equal those both of those equal to 0, and then apply the 0 product property. Y plus 3 equals 0. Y minus 3 equals 0. This is step 2. So now we're going to solve for the variable, minus 3 from both sides. Y equals negative 3. Add 3 to both sides for this other one because it's a negative. Y equals 3. And then step 3 says use a set builder notation to state the excluded values. Both are excluded values. And then I would arrange them from lowest to highest number. So then you're going to say y such that y cannot equal negative 3, 3. Something like number 5. So it says write the expression in lowest terms. So I have the steps for that here. You want to, step 1, see if you can factor out the numerator and the denominator. So we have to look at them as two different expressions. Fortunately for us, the numerator is factored and the denominator is factored. Step 2 says cancel the common factors. So what I mean by cancel is because they look exactly the same, like in the parentheses, I can cancel y minus 4 from the numerator and the denominator. And then lastly, we want to rewrite the simplified expression. So I'm left with, in the numerator, I'm just left with negative 4. And then the denominator, I'm left with y minus 1. And this is our solution. So step 1 was to factor, step 2 to cancel, and then step 3, rewrite the simplified expression. So step 2, step 3. Okay, Okay, we'll look at number 7, 16x to the third plus 4x divided by 20x squared. Step 1 says to factor out numerator and denominator, and the strategies we're going to use for this one is going to be GCF. So in the numerator, that's where we're going to start. I'm going to factor out a 4x, and I'll show that to you in a second. Of 16x to the third plus 4x over 20x squared. So step 1, let's see, we're going to do, let's not do that. Factor out the numerator. So this is, remember this is 4 times 4 times x times x times x, and this is 1 times 4 times x. And then that means my GCF is going to be 4x. Then in the parentheses, I'm going to put 4x squared plus 1. Now I'm going to factor out the denominator. So in the denominator, I have a 20x squared. But we want to use the number 4. So that's going to be 4 times 5 times x. So my GCF there, again, we want it to be the same. So we're going to use 4x. So I'm left with 5x. So that's step 1. Step 2 says to cancel out the common factors. Canceling out the common factors is going to be 4x. That goes away and that goes away. Right? And then step 3, that means to cancel. And then step 3, we're going to rewrite the simplified expression. So we're left with whatever's in the parentheses. You just take out the parentheses. So 4x plus 1 over 5x. And that's your solution. Number 9, z squared plus 10z plus 25 divided by z squared plus 6z plus 5. So what we're going to do is we're going to do step number 1. So we're going to factor the numerator and denominator, and for both of these we're going to do the AC method. So a equals 1, b equals 10, c equals 25. AC is 1 times 25 is 25. b equals 10. So that means that our factors of 25 are going to be 5 and 5. So 5 plus 5 equals 10. So then we're going to factor the numerator. So I have z squared plus 5z plus 5z plus 25. And then I group z squared plus 5z. And then the second group is plus 5z plus 25. Then we want to take out the GCF from the first group. That's going to be 5z. Or I'm sorry, that's going to be z. So I'm left with z plus 5. And then the GCF from the second group is going to be 5z plus 25. So you take out the 5, and then it's going to be z plus 25 inside your parentheses. And then we group them. So z plus 5 times z plus 5. Now we're going to find the denominator of the AC, or I'm sorry, we're going to do the AC method of the denominator. So a equals 16, b equals 6, and c equals 5. A times c is 1 times 5. b equals 6. So AC is 5 and b is 6. So your factors of 5 are 1 and 5. So 1 plus 5 equals 6. So we're going to expand the expression. So z squared plus 6z plus 5 expands to z squared plus 1z plus 5z plus 5. Z squared plus 1z plus 5z plus 5. And then we group, take out the GCF of the first group, which is z. So I'm left with z plus 1. The GCF of the second group is going to be 5, so I'm left with z plus 1. Let's see, so then we regroup. Z plus 1 will be our first group. Z plus 5 is the second group. Oops. And then we are done with step 1. So step 2. Step 2 is to rewrite the rational expression in factored form. So for our numerator, we have z plus 5 times z plus 5 divided by z plus 1 times z plus 5. We want to cancel out the common factors. Remember, they have to be in the parentheses for them to be canceled out. And then we want to rewrite the simplified expression, z plus 5 over z plus 1. And that's it. That's your solution.